I am Bill Mould. I live in Northern Virginia, and I use my knowledge of physics, material science, and engineering to build custom bicycle wheels for people, of which I have made over 4,000. NOX Composites is a little company in Knoxville, Tennessee. Here's their website. It's owned by these two guys here, both of whom are engineers. I don't usually advertise, but there's some pretty neat stuff going on there, and I wanted to bring it to your attention. I'm putting together a very extensive series of videos to delve deeply into the physics and engineering of bicycle wheels, but here I'll just give you a 30-second peek into some parts of it that deal with carbon composites. The starting point for everything is almost always a polymer called polyacrylonitrile. So this is the structure of polyacrylonitrile, PAN, and that's where the abbreviation PAN comes from. And this is the precursor for most carbon fiber products. The precursor undergoes carbonization done at high heat. That creates an intermediate, followed by a second process, graphitization, also at high heat. That gives us a carbon fiber, and the carbon fiber is sold in spools known as tow. You could imagine a large number of fibers laid out parallel like that, and then onto that is flowed in a resin. So I now have a layer or a ply of reinforced carbon fiber, and this is called a prepreg because it is pre-impregnated with the resin. This is a roll of prepreg, which can be cut and shaped into patterns, much like you might cut and shape material purchased at a fabric store. Varying numbers of layers depending on the thickness needed at different points of the rim cross-section are laid up to form the bicycle rim. Here's a half dozen carbon composite rims offered by NOX Composites, and these are all for mountain biking. Here are a few more with some exciting new ones on the horizon. And we're going to focus on the Teocalli 29 shown here.
In the film clip coming next, you'll see a powerful rider coming toward you. Look at how he rocks the bike back and forth as he puts power to the pedals.
Now you're going to see how the engineers at NOX Composites designed the rims to minimize the amount of side-to-side deflection when these obvious and large side loads are put on the wheels. These are some of the dimensions of the Teocalli rim. Here it is without the dimensions. Here it is turned around, and we want to compare these two asymmetrical rims to a third one that I'll show here that is symmetrical. Let's build up two wheels using the symmetrical rims. There's the rear hub, the tire. The tire is centered directly over the hub, and these are the spokes. In the case of the front wheel, we have the front hub, the tire, the center line, and the spokes. Note the small angle on the rear wheel between the center line and the spokes on the drive side, and in the other case, the small angle between the center line and the spokes on the left side. Now let's do the same thing with the Teocalli rims. Starting with the one on the left, there's the rear hub, the tire, the center line, and the spokes. And in the case of the other one, the front hub, the tire, the center line, and the spokes. But there's something wrong with that picture because the holes in the rim are not where I am showing them. There is a 2.6 millimeter offset on both sides, so the spokes actually attach here for the rear and here for the front. This is a better view, and I'm going to take out those centering lines just so we can see the geometry where the spokes are better, and we can see that we have a much better angle. than we had just a minute ago. The improvement in those angles make the wheels much less flexy from side to side when subjected to side loads during a ride. Here are all four graphics shown together. The tires are always centered directly over the center of the rim, which they have to be. I can remove those lines and we see the preferred angles using the asymmetric Teocalli rim compared to the symmetrical rim. If you go to the website, you'll find some more precise data with graphics and vectors shown in, showing the tension vector as well as the horizontal and vertical components and the sum of the vertical components. You have a range of options as to the colors of the decals. And here is the proof of it all. The two guys at NOX Composites gave me a couple of rims to try out for demos, and I put them on this bike here for the rider Adam Swetlow, and he has been riding aggressively all over the place on all kinds of trails and pounding on these wheels for over a year now, and they're still absolutely perfect. Just to summarize, here's our Teocalli. It's a 29er rim, 26 millimeters in width, but it only weighs 380 grams. It has such a low mass because although there's a lot of carbon in it, the density of carbon is low, so you get a very good combination of great strength and low weight. Of course, carbon rims tend to be more expensive than aluminum rims, but here is one that I think is quite competitively priced. Thanks for watching. Here is my contact information.